All right, let's take a look at our lesson for today. We're going to be looking at extrema on an interval. So first off, let's start with the definition. What does this definition tell us? So the definition of extrema. First off, we're going to be looking at, in this case, we're looking at a closed interval, defined on a closed interval. Okay, interval, calling it I for whatever reason, containing some c. This is an x value. So what does this definition tell us? It tells us that this f of c, which is actually a y value, right? F of c is a y value. The y value is the minimum of the function on the interval if that y value is the very smallest y value on the interval, which kind of makes sense, right? That's the smallest y value on the interval. Okay? So then this y value is a maximum of the function on the interval if that y value is the very biggest y value on the interval. Okay? Which kind of makes logical sense, right? And please note, the extrema is the y value. The minimum and maximum are y values, not x values. X values just tell you where they are. There are also some vocab words. So we could say absolute. Absolute means the very biggest, right? That's talking about extrema. Absolute, there's an absolute minimum, absolute maximum, or you could use the word global. Global and absolute, those are interchangeable. You can use either one as a vocab word, and it would be clear what you meant. Now, I do want to tell you that if you just say max, if you just say maximum, that means absolute. It means absolute max. If you just don't say anything in front of it, like global or absolute, it means absolute. So if you leave the word off, you need to be sure you're talking about an absolute extrema. Now we're going to talk about relative extrema today, although our lesson is not on relative extrema, but I really want to talk about both kinds at the same time so that we can tell them apart. How are they the same? How are they different? So absolute extrema is the very, very biggest, or the very, very smallest value. Relative extrema is different. Here we're on, it's not a closed interval, it's an open interval, some kind of open interval. And it contains an x value where the y value is a maximum value. It's specifically a relative maximum value. Here's what is the whole point. This is the point. C would be the x, f of c would be the y. And so that's a relative maximum value. The other vocab word for that is either relative or local. So let me show you a graph where we can kind of tell those apart. Let's kind of see exactly what we're talking about. So I'm going to just draw something over here. Okay, we'll just look at that. Okay. So maximum values, which you probably remember from previous math classes, is just like this tallest value. So consider yourself like you're standing on a mountain right here. Okay, don't laugh at my person. Okay, we're standing on a mountain. We look to the left and to the right. Okay, and we are at the very largest place on the mountain. Are you with me? We're the very largest. But think about it, it's like a mountain range. Okay, just if I look a little bit to the left, a little bit to the right, I'm at the very, very largest place. This would be called a relative maximum, relative or local max, because we are at the very largest y value in the general area. Okay, is it the very largest y value in this whole interval? No, it's not, right? So it's not absolute, it's only relative. Okay, so we can just call this A, we'll call this B, just for fun. All right. So let's continue investigating. Here, I've got this really low value. Is this the lowest y value in this whole interval? It is, isn't it? So this location would actually be the absolute minimum. This is the absolute minimum value right here. I'll just put like a little X right there. That's the absolute minimum value. Now, it can also be used as a relative. It's also the relative min. So absolute mins can also be relative mins. And I'll explain in a minute when they couldn't. Okay, so here we've got another location right here. This location, that looks like the very tallest y value, right? So this is an absolute max, and it's also a relative max. Okay, so what I want to talk about is the endpoints. So let's just look at this endpoint right here. It stops. There's no way for me to tell if this is a relative minimum or not, because I can't see on either side, right? I don't know what's going on over here. Now, could this have been the absolute minimum value? Yes, it could have. It could have been the absolute minimum value, but it's not qualified to be a relative. Why? Because I can't look to the left and the right and see whether it really truly is or not. Are you with me on that? Does that make sense? So now we know why let's say this right here, this endpoint right here, it could have been an absolute max. It could have been. It's not, but it can't be a relative max. Why? Because I can't see what's going on to the right. Okay, so that's basically just like in a picture, in a graph, how we tell the difference between absolute extrema and relative extrema. All right, so we have one example on absolute and relative extrema right here, just from a graph. And then we have one other concept to talk about. So here we've got another graph right there, and they want us to find, let's see, does F have an absolute maximum? Well, I mean, yeah, this is the very biggest point. Absolute maximum would be at 421. Is that also a relative maximum? No, it is not, because I don't know what's going on to the right of it. I just don't. So no, it's not. Do we have an absolute minimum? We do, right here. Our absolute minimum is at -2, -15. Is that also a relative minimum? No, because I don't know what's going on to the left. We do have a relative minimum and a relative maximum. Let's see, relative maximum we've got at 0.5. Okay, we see that. So right here, there's a relative maximum. It's the largest location in the general area, like on a mountain range. And yes, we have a relative minimum at 2.1. Again, because this is the smallest y value in the general area, just in this specific area right here. Okay, are we all okay on the difference between relative and absolute? We good? Okay, one other concept to look at is the concept of critical point. Okay, it's pretty important. Critical points are important. And I put a little box around domain because in order to qualify as a critical point, it has to be in the domain of the function. It has to be. And we'll talk about that with an example in just a moment. Now we have two kinds of critical points. We have where f prime is 0. This is called, has a name. When f prime is 0, this is called a stationary point. Yes, these are formula quiz questions. Then we have our little friend undefined, which this poor little thing gets forgotten so many times. Sometimes if the derivative is undefined, that's the second type. The first derivative is undefined, and that is called a singular point, where f prime is undefined. All right, so let's talk about these points. I've put them on a formula quiz before, and sometimes it will say like, it'll just say stationary point, and you have to say what it is. Stationary point means f prime is 0, a critical point where f prime is 0. You can't imagine some of the responses I've gotten on the formula quiz for a stationary point and singular point. I've gotten a point that doesn't move. Really? No. A stationary point is where f prime is a critical point where f prime is 0. A singular point? No, that doesn't mean there's just one point. That means it's a critical point where the first derivative is undefined. So just want to make sure we're clear. And this is really important. Relative extrema can only occur at critical numbers, period. No other place. It's a theorem. Relative extrema occur only at critical numbers. Okay. We doing okay? All right, so now let's get to our main focus today is on absolute extrema, absolute maxes and mins, and we have a theorem for that. It's called the extreme value theorem. It tells us if f is continuous on a closed interval, okay, so two things have to happen. Number one, it has to be continuous, and number two, it has to be a closed interval. If those are true, then f has both a max and a min. And they're using the word absolute. Absolute max and absolute min. Did I have to put the word absolute on here to mean absolute max or min? No, I could just leave it like that and it would still mean absolute. But for relative, I have to say relative, okay, or local. I can't leave that off of that one. I have to say that. So let's look at our test. We call it the candidates test. It's going to happen. We're going to have to use the candidates test on any kind of test, an AP test or one of my tests. It'll happen. So what do we do? So to find the absolute extrema of a continuous function on a closed interval, notice they're just re-saying what the theorem says. What do? Number one, you find the y values of the critical points. You find the y values of the endpoints. And then you test them. The smallest of the values is the min and the greatest is the max. Yes, I love putting this on a formula quiz. It's another 3. There's 3 parts. 1, 2, 3. Okay. I'm going to pause here for a second. Are there any questions about the test itself? We're going to practice it in just a minute, but are there any questions? Okay, let's practice. So our first one, they want us to find absolute maxes and mins. Okay, that's fine. We can do that. What do we need to do? We've got a closed interval. Okay, we pay attention to that. That's our closed interval. So I need to find the derivative. F prime would be, we're using a power rule. Let's see, 2/3 times 3 is what? 2. X to the 2/3 minus 3/3 is negative 1/3. Minus 2. Okay, there's my derivative. So to find the critical numbers, what do I need to do? I need to set it equal to 0. Find my zeros. So 0 equals, and I'm going to actually rewrite this so it's a little bit easier for me to work with. 2 over cubed root of x minus 2. Okay, so I'm just rewriting it just to make my life easier. So to solve, I would move the 2 over. Okay, I would cross multiply. That's how I would solve it. There are other ways to do it. I'm just showing you what I would do. So that would be what? 2 cubed root of x equals 2. So I divide by 2. So I've got cubed root of x equals 1. So x is 1. Cube both sides, I get 1. Okay, that's a critical number. That's which kind of critical number? That's a stationary point, right? That's where f prime is 0. That's a stationary point. We need to look for the other kind. The other kind is a singular point. What kind is that? Undefined. Is this, and I'm focusing on this, is this derivative undefined for any value of x? Is it? X equals 0. It is, right? What would happen if I put a 0 in there? Wouldn't that be bad? Wouldn't I get 2 over 0? That's bad, right? Okay. Is 0 in this interval? It is. So yes, that qualifies. So here's my critical numbers. So my critical numbers, we'll just write, be specific. I'll say f prime equals 0 at x equals 1. That's a stationary point. And then I've got f prime equals undefined at x equals 0. And that's a singular point. That's the type. Okay, so what am I going to do? The candidates test requires me to check those numbers. I'm going to do it with, I'm going to put it in a table. There's other ways to do it. This is just one. So I need to check the critical number of 1 and 0. Those are critical numbers. What else am I supposed to check? The endpoints, right? I need to check the endpoints. So I need to check -1 and 8. Got to check all of those. Where do I put those in to check them? What am I looking for? I'm looking for the biggest y value and the smallest y value. Where would I go? Would I go to the derivative to put those in? No. Is that going to give me the biggest y value on the graph or the smallest y value? No, the function will. I go to the function. So I'm go to the function, and I'm just going to save time. I've already plugged those in. I'm just going to write the answers down, okay? I've already plugged those in. So 1, I was a 2, 0 was 1, negative, can I write? Yes. -1 was 6, and 8 was -3. Okay, those are my numbers. Now, I will tell you that just writing those x values down, the critical numbers and all the candidates, they're called candidates. These are candidates. Writing the candidates down generally gets you like a point on the AP test. You don't even have to use the candidates properly. If you just write them down, you get a point. Please remember to write all your candidates down. Okay, write the candidates down. And then we tested them. Is there a very biggest y value? There is, right? It's 6. So we're going to say absolute max equals 6. And we'll just put the point just for further clarification. Okay, that's the point. -1, 6. If they want to know the x value, well, it's right there. So that's our absolute max is 6. Because the max is the y value, not the x value. The max is the y value, not the x value. Let's see what they said. Find the maxes and mins. They're asking you to find the y value. What if they say find where the maxes and mins are? What value would we be working with? The where is the x value. Okay, and do we have a minimum value? What's the very smallest y value? -3. And I'll just write the point down, 8. -3. Okay, there's our very first candidates test. How are we doing? Yes.
So, which equation did you plug the x's in to get the y's?
So what we want to do is we want to go back to the original equation to plug those in. Because this is the equation, that's the position equation. This tells us where all the positions are. So we want to know the biggest y position and the smallest y position. Okay, anything else? Okay. Our second and last example, trig. Yay, yay. I love trig. Okay. This little guy right here is, poor thing, the derivative is taken incorrectly of that little guy all the time. No, the derivative of sine squared is not cosine squared. No, it is not. What is it? It's a power chain. I need to write it like this, right? I got to write it like that. This is a shortened notation. This is like a mathematical shortcut to put the 2 there. That means the function is squared. That's what it means. That's a shortcut. We can't take the derivative using the shortcut. You need to take it this way. So f prime is, bring the 2 down, 2, copy paste, 2 minus 1 is 1, times the derivative of the inside. What is the derivative of sine? That's cosine. The derivative of cosine is negative sine. And that's my equation. What do I need to do? I need to find the zeros. 0 equals 2 sine x cosine x. Now, some of you might want to move the sign to the other side and divide it off. Now, let me say there's nothing algebraically incorrect with that, but if you do that, you're going to erase half of your answers. Don't ever do that. Don't ever divide off one of the trig functions. Don't do it. Or an x. Don't do it. So instead, we're going to factor. Yay, factor. I'm going to factor out a sine. Leaves me 2 cosine minus 1. I set each factor equal to 0. Okay, we do our lovely unit circle. Where is sine 0? Sine 0 here and here. So let's see, and we only care about 0 to 2 pi. That's all we care about. All right, so let's see, x would be what, 0, pi, and 2 pi. That's where sine is 0. Let me fix this. So this would be what, move the 1 over. So this would be, where is cosine 1/2? Okay, cosine is 1/2 right here and right here. Okay, that's what, pi over 3. And I know you really want to write the negative pi over 3, but you can't. Why? Because it's not in the interval. We only care about 0 to 2 pi. So it'd be pi over 3 and 5 pi over 3. Okay, let's make our table, our little chart. Now, strangely enough, these endpoints also happen to be critical numbers. Now, these are where f prime is 0. Is there anywhere f prime is undefined? Are sine and cosine undefined anywhere? No. No, so I don't have the second type of critical numbers. I don't. Okay, that's fine. So we've got 0, pi, I'm just going to try to put them in numerical order. 0, pi over 3, pi, 5 pi over 3, and then 2 pi. Now I have already calculated these, and where am I going to put them back in? The original, right? I'm going to put them back in here. That's where I'm going to go. So I did that already, just for time's sake. I'm going to go ahead and write down what I got. So 1, pi over 3 was 5/4. Pi was -1. 5 pi over 3 was 5/4. And 2 pi was 1. Okay, do I have a very smallest y value? I do, don't I? So my absolute min is -1. Where does it occur? Let's just write the point down. It occurs at pi -1. Okay, what is my absolute max? What's the absolute max value? 5/4. Now, does it occur more than once? It does, and that's okay. It's okay to occur more than once. It's not a problem. I can write down, I can list them. So it occurs at pi over 3, 5/4, and it occurs at 5 pi over 3, 5/4. And those are our absolute extrema. How we doing?